hello, and welcome to the show. It is JP's product pick of the week, and this is me, JP. And the first thing I want to do is have you head on over to the page where the product resides, because if you head to this URL or over to this QR code, you will find that this week's product pick is half off. A tremendous savings, and this video is playing right inside of it, so you can watch it from right inside the product page if that's your jam, if that's what you like to do. Why don't you do it? So, in fact, if I head over there right now, I'm just going to refresh, we will see that, yes, indeed, half off, and that's the page, but I've gotten ahead of myself, so why don't we jump back a little bit and have Lady Ada tell us a little bit about this week's product pick. Please take it away, Mrs. Lady Ada from the past.
NeoTrellis. So this is what people have wanted from the moment we had Trellis, an RGB Trellis, and as you see here, this is our little demo, and this is just showing one panel. So like the Trellis boards that we've sold before that were LEDs, you get these boards, and each board does a 4x4 grid, and then you can tile them together, as many as you want, up to 32, which is a lot. And this is all done over I2C using Seesaw. So this is an I2C device. We have an interrupt pin if you want to use an interrupt input, but you don't need to. You can just pull the I2C and it's plenty fast. And on the other side is NeoPixels. And the NeoPixels are also handled over Seesaw. So again, you don't have to worry about what if I have a Raspberry Pi or an ESP32 and it's not great with NeoPixels. It's all done over I2C. So I have a demo of a massive grid. So like you're wondering, but what if I want more than 4 buttons? Well, you can tile them together. So you see you solder here, this is a mechanical connection, and on the bottom you have the I2C and data pins, and you put a little piece of wire and you solder them, and like, yeah, don't like try to break this, but if you don't try to break it, it's not going to break. And it stays nice and solid, and then of course you solder all 4 together for mechanical strength. And then you only have to connect to one because it's just shared bus. And each one of them, the I2C jumpers, you short them so that each one has a unique address. And in the library, you just tell it, hey, you know, I've got 4 boards. And then you get these elastomer pads that we sell, and they're sold separately. And then you just line up the pads. There's a little nubs, and then they sit nice and flat. And I'll leave this one off so you can see it. And then here's a demo. It's just running off of a Gemma M0, unless I killed the battery, which I think, hold on. Let me plug it. Oh, there you go. So you can see these are the NeoPixels, and then these are them diffused. And that's like a little rainbow demo. And then you can press each button, and then you can do multiple button presses. It uses diodes, so you can press as many buttons as you like. In fact, you can press all of them. So many buttons. You can just go bonkers with all your button pressing. You can detect as many presses as you like. This one stayed on. And then you've got full color, and then you can control them separately. So in your code, you read the button presses, you can have a callback, and then you can set it to do whatever you want. So for this demo, I just have it when you're pressing it, it lights up a color, but of course, you know, you're free to do whatever your heart desires. Tile as many of these as you want. There you go, everybody. You wanted a NeoPixel Trellis, you got one. Finally, all your desires have been met.
All right, that settles it. I'm going to head over to my magical cabinet of drawers full of neat stuff and grab one for myself. Hang on right there. That's right, my product pick of the week is the NeoTrellis. This is a driver board with a row of 4 and column 4, so 4x4. What am I trying to say? This is the driver board with 4x4 NeoPixel LEDs and the contact pads for pressing with an elastomer pad. This is sold separately. And we can drive this over the I2C bus from nearly any microcontroller. We have great libraries in CircuitPython and in Arduino that you can use. And one of the cool things about this is that you can use it stand-alone or just one of them connected to a microcontroller, or you can tile up to 32 of them for a whopping 512 buttons, which is totally bananas. You may have challenges powering that without using an external power supply if you turn them all on. But you can certainly run these off of a microcontroller in more moderate numbers. And what I want to do is give you a little overview of these and then show you a few demos of them. So first of all, like I mentioned earlier, this is the website. So if you head to, this is product ID 3954. A little trick, when you hear an Adafruit product ID, you can just go to adafruit.it/ and whatever that number is, and that's the short URL that'll get you there, or adafruit.com/product/ and in this case 3954. You can see here we have some lovely photos of the board, front and back side, and then we have some little videos. Here's a nice photo of a pair of them set next to each other, so these tile in all directions. And then if you scroll down a bit, you can click on the primary guide link as well as some links to some different projects. So if we head over to the primary guide, you'll see here we have the pinout diagram that'll tell you what's connected to what. We have info on tiling, which, since this is over the I2C bus, what happens is you connect multiples of these together, and then there's a little jumper on the back here, a little set of jumpers that you will solder together in order to create different addresses. So as long as you have unique addresses, you can talk to multiples of these that are connected with only one I2C bus, only one connection to your microcontroller. So here's a nice picture of a set of 4. And then here's a little info about addressing, so a little cheat sheet for the different hex addresses for your different boards. And let's take a look at it in action now, shall we? So let me jump to a downshooter. How about this view here, actually, and then I'll just jump up in the corner. How about that'll do it? So I have a few here I want to show. First one, I'm going to take our board here, and you can solder wires to these pin connectors on the sides in order to solder into another circuit or connect to your microcontroller. Or you can plug right into this 4-pin stemma cable. So here I have a JST4PH to SH, which means on one end I can go to stemma QT, and the other I can go straight into the board. Plug that in there. There we go. That was harder than it should have been. And so now I'm connected right to this feather, and I'll actually leave it bare for a second. It's going to be pretty bright, and let me just switch over so I can see my. Yeah, question from Doctor, is that a giant stemma connector? It is. This is stemma light up. It's going to run through all of the pixels as purple, then it brings them back on as yellow. And now in order to press the buttons, these are actually just contacts, copper contacts, that need to be bridged together using the carbon infused rubber that's at the end of each of these little silicone pads. So I'll go ahead and set this on here, and now you can see when I press one, I just have it turning red while it's pressed, and I have it turning blue when I release. And that's all this does. It's nothing fancy, just a little light show. But of course, you can have this send out USB or MIDI commands, which is a really typical use for these. What I wanted to do is actually show you the code for just this simple example here. So let me swap views again, and let me open up my, let's see, is this the one I want? I want this other one here. I have two similar bits of code running. So you can see here I'm bringing in the I2C pins, the serial clock and serial data line from bus, and I'm bringing in the bus I/O and the NeoTrellis library. So the NeoTrellis library takes care of the button matrix as well as the NeoPixels that are there, so it makes it easy to talk to. So I've created a NeoTrellis object on the I2C bus. I've set up a variable containing some colors. I've kept them pretty dim so that they don't blow out the camera here. And then there's a function here created called the blink. And when blink is either sent a button press or a button release, it does one of two things. It's doing an edge detection. When it rises, we're going to set it to red, so that's when I press it. And when it releases, it sets it to cyan. Then we have the little intro animation here. So if I just reset the board here, you'll see it run through that. That's this I in range 16. It just runs through and changes the colors of those. And then the entire set of code is just trellis sync. So it's just checking to see something happened on here that we need to react to. And depending on what that is, we use one of these functions here. So that's it, really simple code. Now I have another example here. One thing that's nice is to create or laser cut or 3D print or cut out a cardboard or some other material, a sort of a light blocker grid. And so I have one here I've done with some 3D printing. So I 3D printed a neat little case here. And what this one has is a Cutie Pie running it. So small little microcontroller in there. It's actually a Cutie Pie RP2040 and a nice little 3D printed case. And then you can see here I have it doing a similar bit of code, except this one runs through randomly some of the different colors that are defined in those variables. So this is just a little light game. This actually came from a Ruiz Brothers guide that shows you how to make this game, which is sort of just a fun fidget thing, especially great for kids. You press a button until it gets to the color you want. Maybe you light them all purple or something like that. So there's a nice little case here. All I'm going to do is pop this off. I just have some Kapton tape holding that together. You can see what's inside. I have Cutie Pie, again wrapped in some Kapton tape, so nothing shorts, and then my USB cable running right to it. So that's it, very simple setup. And this 3D printed case is available. I made a shorter version of it, but that case is available in the Ruiz Brothers guide. And then what I wanted to do, first of all, I'm just check in on the chat to make sure everything's good. Looks like we're not out of sync yet, hopefully. I see some YouTube quality issues that's yelling at me. And I want to say hi to people over in YouTube chat. Hello, Dave Odessa, Anthony Becerra, and You Do It. Nice to see you all. Thanks for coming by. So, yeah, there's a link in the chat that Todd bought. Thanks, Todd, just put up with the Trellis box game, which you can power this off of a battery very easily. Particularly a little LiPo battery is a nice way to do it, to make it portable. And now what I want to show you is actually a really advanced example of what people have done with the boards. So I'm going to reveal here my 128 button monome grid. So this is a set of 8 of the NeoTrellis boards connected, and then a nice laser cut case. And this is a design, let me go to the web page here for it so I can show you. This is a design by Denki Otto, or Steve, or OKUron in our chat. He goes by many names. Where is it? Here it is. So this is OKUron NeoTrellis monome on GitHub, and you can just search for NeoTrellis monome. This is a DIY version of the monome grid, which is a music instrument controller, general purpose controller that can be used for a lot of different things, depending on what software you write for it. And he's got some great instructions on setting this up. Here you can see the tiling and the address jumpers that are being set. And this runs off of a Teensy 3.1 or 3.2. So I'm using mine to run a little Raspberry Pi-based musical instrument, also made by Steve, designed by Steve, called Fates. This is essentially a DIY version of Norns, also from Monome. And if I turn this on, I'm going to turn up my mic on my amplifier over here. Let me go to a full view of that, and I'll just hide up in the corner here. So this is pretty cool. This is the software I'm running on it is a sequencer that is based on little note patterns that you create, and then when we create essentially intersections, trigger MIDI things, or in this case I'm triggering an internal synthesizer. Turn this up a little bit. And one of the cool things with this is that you can then control that pattern. And this is shifting the scale of what we're hearing. Turn this up even more so I can hear it better. And let me know in the chat if that's audible before I go on. I'll noodle around with this for a moment while you check it. Okay, hard to hear me over the beeps and boops. Got it. All right, let me lower that. Now you tell me. The very loud beeps and boops. Okay. And oh, I see. I can look at the levels there. Hey, now my level is approaching that of the beeps and boops. Much better. Okay. Loud on YouTube. All right. So hopefully you can still hear me. So yeah, this is really cool because we can create little note patterns even on the diagonal. Make a little fast one here. You can hear I'm shifting that pattern. And look how responsive this is. So this is using sort of variable brightness with just a single color, but you could pick any color for this if you adjust your code. And watch how quickly this isn't very musical what I'm going to do, but it'll respond really fast. So you can see my grid updating. Really nice fast changes there. Let's see if I can find and turn these off. They get hard to figure out where they start and end. Not there. All right, I hit clear. That'll do it. So that's a nice example of an instrument made using a bunch of these. We also have our famous original instrument, UNTZ, which was made with the original trellis boards. I still have a trellis regular one over here somewhere. Here it is. So this was the original, right there, original trellis, and this used a single color LED. You would solder in your own set of 16 LEDs, pick the color you want, but it was a fixed color. I think we could PWM brightness, but I don't recall exactly. But you can see how nice this is, like Lady A was saying, to be able to now, I'll turn the volume down on this entirely, to now, or I just won't make it make any sounds, to have multiple colors, multiple shades, or values of brightness on here. Really fun to work with. And so that's an advanced demo, but you can imagine, especially with 50% off right now, if you head over to the Adafruit store and head to this page. Hopefully we still have them in stock. I don't see any stock warnings. Maximum of 10 per customer. You only need 8 to build this grid. There's also a version of 64 pixels, so 4x4. Go all the way up to 256 if you want for Norn's software. Or if you're writing your own thing from scratch, like a giant MIDI thing, then you can go up to 512. But you will need probably an external power supply. So let's see. I think that's going to do it. That is the product pick of the week. So that is the product pick of the week. It is the Adafruit NeoTrellis. Hang this up here. Where's the next one go? Right about there. That ought to hold. All right, well, thanks everyone for stopping by. Head on over to the Adafruit store to grab some. The special 50% off is only good during the show. We have a few minute grace period. And I want to thank you for stopping by. Thanks, hey, Eric Laird, James Driscoll, TMP, and Mike L. Thanks for showing up over in the YouTube chat. And you're welcome, Mike. Mike likes the Parsec videos. I appreciate it. Thanks in our chat, Dr. OK, you're on, Todd Bott, Yanisku. Special thanks to OK, you're on for developing this DIY version of the monome grid. Really fun to play with and makes it accessible to more people, which is great. It's a big open source community of software development, so it's really nice to support that with some roll your own hardware. Todd has an 8-foot by 6-foot wall. How many NeoTrellis boards do I need? Yes. You figure that out, Weisenheimer. Hey, Dexter Starboard, Jim Hendrickson, thanks so much. Thanks, C. Grover, for Adafruit Industries. This has been JP's Product Pick of the Week. That's me. I'm JP, and I will see you next time. Bye-bye.